Let's talk about eliminating data center complexity with EVPN-VXLAN. We'll begin by considering some of the challenges in modern enterprise data centers, such as always-on 24/7 operational models, which means there is no real downtime that you can count on or any time when you can take the network out of service. Another problem that many networks in modern enterprise networks today face is having heterogeneous operational models or old and new systems running in parallel. Another problem they face is trying to simplify their networks to find a single solution for many different problems. They also need to make sure that they have high-speed networks for high-performance workloads. This includes having a lot of bandwidth, but it also includes things like jitter and delay. Another problem that enterprise networks face today is unpredictable workloads and the scale issues that go with those unpredictable workloads. Now let's look at some of the technical or the different concepts that you can use from a design and architecture perspective to solve some of these problems. For instance, resilience will help you with your always-on operational model. Agility will help you with your old and new heterogeneous network models, and your scale. Scale in particular is something that you need to have a lot of agility to deal with. Speed, of course, is also impacted by agility of the network. Having an open architecture can help you with heterogeneous operational models, and it can also help you with scale, because as you can scale things, if the architecture is open, it allows you to modify or to change things as needed. Low latency in the network architecture can help you with speed, of course, and then design simplicity will help you with your 24/7 operational model, your heterogeneous operations, your single solution for many problems, and other things. East-west traffic growth is a major problem in most modern networks. This is primarily driven by problems around scale and unpredictable workloads. Let's talk about some of the technical underlying things that you can do to solve these kinds of problems. For instance, you can use a scale-out design. This gives you agility, and it also helps you with your east-west traffic flow problems. Fast failover, the ability to quickly reroute traffic when a link or a node or a router or switch fails, contributes to resiliency and agility. The load sharing aspects of a solution will help you with your low latency, as well as helping with resilience and agility in many cases. Any service anywhere, being able to apply any service anywhere, can help you with design simplicity and east-west traffic growth. If the design or the architecture is vendor agnostic, this can help you be more agile, and it also plays into the open architecture. Shallow learning curve helps you to be more agile, as well as playing into open architecture. You also want to have leverageable technology. This means you're going to have agility and open architecture. So let's look at some solutions or some areas of EVPN design that help solve these specific problems. EVPN typically relies on an IP fabric underlay. Now you can use MPLS underlays as well as IP fabric underlays, but using EVPN with VXLAN allows you to use just an IP fabric underlay. This helps you with scale-out design and load sharing. Active multi-homing, which is a native part of EVPN, allows you to handle fast failover and load sharing, which then backs into the ability to do low latency and agile operations. Distributed Anycast will help you with load sharing as well at the application level. Multi-tenant capability, which is also built into EVPN over VXLAN, allows you to run any service anywhere and allows you to leverage your technology, this single technology, across many different places in the network. Because EVPN-VXLAN is standards-based, it's also vendor agnostic. So this allows you to deploy many different vendors in a network and to deploy those things in a way that allows you to use all of them to their fullest extent. Because it's standards-based, this also allows you to have a shallow learning curve. While EVPN-VXLAN is a rather complex technology, it is standards-based and it is open so that many people can learn this technology and understand how to support it. Supporting multiple data planes allows you to be vendor agnostic, have a shallow learning curve, and also allows you to leverage technology. By this we mean not only does it support an IP underlay, but it also supports MPLS as well. It can support GRE tunnels, VXLAN tunnels, or many other underlay or data planes in the network. Having a single control plane everywhere allows you to leverage a single technology in many different places, contributes to a shallow learning curve, also contributes to being vendor agnostic, and allows you to run any service anywhere. So let's look at some things about EVPN over VXLAN that allows you to do some of these things. Let's begin by thinking about how I would use EVPN, specifically EVPN over VXLANs. You can use EVPN in your data center fabric. Of course, you can use it with an MPLS fabric as well, but the primary use case we're talking about here is over an IP fabric using VXLAN. You can use EVPN over VXLAN as a data center interconnect. So if you have a dark fiber WAN or a dark fiber interconnect between two data center fabrics, you can use EVPN to interconnect those two data center fabrics. You can also use EVPN to do WAN integration to allow you to connect various parts of your network that are connected together over a private or public WAN across whatever there happens to be there using EVPN, a single control plane, because it runs on top of straight IP. It also allows you to do hybrid cloud connectivity. So you can take your data center fabric and connect it to the public cloud using virtual instances of Junos routers in the public cloud that allow you to interconnect through EVPN between the public cloud and the data center fabric. So let's look at some of the things that are under the hood. We need to begin here by thinking about what does under the hood, or why does under the hood really matter? This is because the right technology choice sets the right foundation for any particular network design. Flexibility gives you a Swiss knife approach, a lot of tools coming out of the same subset or the same tool set that allow you to carry something very simple in your pocket but solve a lot of different problems. This is available in EVPN because the EVPN control plane is decoupled from the data plane. You can use many different data planes under an EVPN control plane, including VXLAN, MPLS, segment routing, Geneve, GRE, and other things like this. This also allows you to cross-leverage design options in your network using a single network technology, EVPN over VXLAN, for many different problems. In the operations realm, EVPN allows you to reduce your overhead. This is because you are using a cross-leverage design option across many different places in your network. You will have a common troubleshooting procedure both for the data center interconnect, and for your wide area network. This allows you to have a least common denominator, which allows you to reduce your learning curve for your facilities, for your NOC, and for your network reliability engineering area. This also allows you to easily certify the network and the design because you're only using a single network technology across many different places in the network. Extensibility is there with EVPN because you can easily pre-provision a lot of things across the network. You can pre-provision to support the legacy with the new, allowing you to do heterogeneous network support. You can also turn on EVPN routes to carry MAC addresses for Layer 2 extensions or legacy islands. Again, this allows you to have a unified service or a unified solution, having IP VPN-like policies to support customization across the network. Supports link efficiency through all active forwarding with loop prevention in different points in your network at your DC edge and on the WAN side where you might have multiple links. It has built-in HA and fast convergence and fast reroute capabilities, which gives you fast convergence in the network. At Layer 2 and Layer 3 at Ethernet and IP, it allows you to have multi-tenancy, which allows you to carry workloads across the network in different places. You can optimize your DC ingress and egress for VM mobility so that the right traffic goes to the right place and you don't have tromboning effects. So let's talk a little bit more deeply about EVPN and EVPN design. First of all, EVPN on top of IP uses a scale-out topology. That means that instead of adding bigger boxes in the core of your network, you're adding more boxes sideways. You're scaling out the network. It relies on an IP fabric underlay, which allows you to use routing in the underlay, which controls the failure domains and allows you to use fast reroute and fast convergence IP topologies on your data center fabric. It allows you to use simple overlay segmentation. So both Ethernet and IP overlays are supported with EVPN so that you can carry workloads back and forth between data center fabrics. And this also is allowed with optimal traffic flows. Because the routing information is proactively carried through EVPN, you never have to worry about the traffic flowing suboptimally through the network. There's also open standards edge redundancy. So rather than using something like proprietary MLAG protocols here at the edge, you can use EVPN MLAG, which allows you to have redundancy at your edge. EVPN designs using VXLAN also allows you to do optimized multicast replication. This is because multicast can be replicated where it needs to be replicated in the fabric, say here or here, rather than being carried all the way to the top or the core of the network in order to be replicated. You can have a single control plane running on both of these fabrics and running over the DCI link between these two fabrics, or the set of DCI links running between these two fabrics. If you move a workload between these two data center fabrics, it will optimally pull traffic to the right data center fabric and carry the traffic through the fabric to the correct workload. So a high-level blueprint might be to look at your access, your underlay, and your overlay layers and understand how and where to place things like all-active multi-homing, whether to use an IGP or BGP underlay. Options like Rift or ISIS are out there for use in the underlay, or you can use eBGP if you want to. The overlay in EVPN allows you to place your gateway either on the leaf or the spine in order to provide optimal traffic flow through the network. You can use distributed layer 3 gateways, which allows you to use anycast gateways with the same IP and MAC address at multiple places in the network. EVPN uses IBGP and, of course, eBGP to do network layer reachability information exchange. And BGP is a very scalable, proven protocol used in the global internet. You can use route reflection at the spine or in the fabric layers in the top of rack or above the spine or below the spine in order to scale BGP in these networks. EVPN has a service interface that is VLAN aware, VLAN based, and has VLAN bundles as well. You can actually run EVPN all the way out to the host, and you can allow host communication between inter-subnet and intra-subnet using Type 5 and Type 2 routes. So how can we bring all of this together into a single, easy to use and easy to manage network for enterprise operations? First of all, you can hide all the complexity under the hood by using Contrail Enterprise Multi-Cloud for your fabric management. This means at day 0, you can do design and initial provisioning using zero-touch provisioning on board, and you can perform hitless fabric upgrades. This also allows you to build and configure new fabrics or to manage an existing fabric using the Contrail Enterprise Multi-Cloud. On day 2, you transition to a management and operations mode where you can identify and common and difficult to diagnose problems such as interface problems or link utilization issues, gray failures, things like this in your fabric, again using Contrail. You can view device profile to check system health as well. So all of this allows you to build a very effective and easy to manage data center fabric, pulling everything together using EVPN over VXLAN, and a single pane of glass using Contrail on top. Thank you for listening to this little presentation on EVPN over VXLAN and how it can simplify your network.